So as I told you, neuroeconomics is very much dominated by neuroscience. But neuroeconomics combines psychological, economic, and neurobiological approaches together. And for people here with a background in natural sciences, or in the background in physics, in neuroscience, it can be a bit surprising that economics has something to do with decision making. But for economists, it is obvious. So, of course, economics is a science that investigates the production, distribution, and consumption of wealth. But traditionally, economics is split in two subfields: macroeconomics, and macroeconomics deals with nations, with world economy as a whole. But there is a second subfield, microeconomics, and microeconomics focuses on the behavior of specific sectors and specific individuals. So macroeconomics is very much interested in individual decision making, for example, in decision making of consumers or financial decisions. Traditionally, microeconomics focuses on decision making. That's why it would be very interesting to combine neurobiological and economics approach. So recently, economics was very much affected by experimental paradigms. So for example, behavioral economics, experimental economics were created. So it's not surprising that Daniel Kahneman and Vernon Smith got Nobel Prize in 2002 because they transformed the ideas in classical normative economics. These two people are very influential people also in the field of neuroeconomics. Their ideas stimulated a lot neuroeconomics, and they both participate in their various activities of the Society for Neuroeconomics. So really, neuroeconomics gain a lot from economics, from experimental economics, from behavioral economics. But on the other hand, of course, neuroeconomics was created by neuroscientists. For example, Paul Glimcher, godfather of neuroeconomics. He is a prominent, well-established neuroscientist. So he conducted very influential neuroscience study in New York. He investigated monkeys' behavior. But at some point, he got interested in economics. He actually attended classes in economics and got the idea to combine economics and neuroscience. And still, right now, I think he's the most influential neuroeconomist. But whenever you attend neuroeconomics meetings, you will see neuroeconomists, and basically you will see psychologists, economists, prominent neuroscientists discussing various aspects of decision making. So core neuroeconomics is a subfield of neuroscience, and it really tries to combine various approaches in order to build a theory of decision making, theory of our behavior. But the extended version of neuroeconomics is much more ambitious. This is a multidisciplinary field that tries to understand decision making by integration of evolutionary, neurobiological, and various social approaches. So extended version of neuroeconomics tries to build a unified theory of our decisions. So of course, neuroeconomics currently is a subfield of neuroscience. And neuroeconomics tries to understand how our brain produces our decisions. And my personal way to neuroeconomics started when I attended a seminar and I saw this video clip. You see here metallic processes, an artificial arm directly connected to the brain. So the decisions of the monkey can be detected using implanted electrodes and translated to the electrical signal and enable monkey to manipulate the hand and feed itself. So already more than 10 years ago, we were able to detect simple decisions of the monkey and translate it to an electrical signal and enable monkey with fixed hands to manipulate artificial processes. So once again, these processes is directly connected to the brain, and monkey can translate decisions into an electrical signal. So already 10 years ago, we could say something about the decisions programmed in the brain. So currently, we face a revolution in these technologies. So for example, here you see an example of a patient who were nearly 15 years paralyzed and unable to speak. So currently, she is able to control a robotic arm and feed herself. You see on the top of her hand an interface that connects directly brain, motor cortex of the brain, to the artificial processes. So we somehow can detect her decisions and translate it to motion of the artificial hand. So currently, these very small micro interfaces can be implanted of the brain and help paralyzed people. So their decisions can be detected and translated to a signal supervising the artificial arm, for example. So here you see an example of a person who is paralyzed, but she is able to feed herself using an artificial processes directly connected to the brain. So we face a revolution in technology. And of course, currently we can detect very simple decisions, intentions of the subject. But already now, amazingly, it can help people to, for example, use artificial processes. So you see here, once again, this study in the University of Pittsburgh after 10 years of various experiments. And you see how this neurotechnology is progressing. So already now, we can detect decisions. Of course, these are very simple decisions, and help paralyzed people to use these decisions, translate these decisions into the motion of the artificial arm. But we face a revolution in neuroscience techniques. I will just give you one example. This is so-called optogenetics. So these methods, just very new methods, and neuroeconomics starts to use these methods in the studies of decision-making of animals. It will just give you a hint about the progress and technological revolution in neuroscience. So you see a source of light on the top of the head of this rat. So this is a very high-end technology. Imagine that we can construct a gene that programs certain artificial protein. We can put this gene into a virus. We can infect the brain of the rat by this virus. After that, brain starts to produce these artificial proteins. These proteins are integrated to the neurons, into the neuronal membranes, into their ion channels. But these artificial proteins are sensitive for the specific wavelengths of the light. So if you apply a specific wavelengths of the light, you can change the structure of this protein. And these proteins can open and close ion channels of their neurons. So by light, you can open and close ion channels in neurons of the rat. So by light, you can switch off, switch on different brain regions and investigate the role of these brain regions in behavior and decision making. So you can see here a combination of various techniques and an enormous progress in technology of neuroscience. Of course, this will affect the field of neuroeconomics. It will give us new tools to investigate decisions of animals and of humans.